Hello Year 10 and welcome to our fourth lesson of the electricity topic. Today we're going to look at the subject of electrical resistance. We're going to examine the term resistance and what it means. Okay, quick thinking task for you. You should have had a go at the starter questions. Hopefully they have got you kind of your brain in gear, but just to get us thinking first of all, okay, this question says, in a shop, you can buy a 1.5 volt battery or a 4.5 volt battery or a 6 volt battery or a 9 volt battery. What I want to know is why you cannot buy a 1.5 amp or 4.5 amp or 6 or 9 amp batteries. Why are our batteries in volts rather than amps? So that's your thinking task to have a think about whilst you're waiting for your lesson to start or while you're getting ready and set up. You can pause the video. I'm not going to reveal an answer for that right now. I want us to consider that over the next lesson or so. So today's agenda, we're going to look at what is resistance. We're going to look at how resistance affects a circuit, and then we're going to use Ohm's Law to work out some resistance problems. So make sure you have pen and pencil ready and a calculator and your notes book. So what do we mean by resistance first of all? Well, resistance is the electrical resistance of an electrical conductor, i.e. any circuit component, is a measure of the difficulty to pass an electric current through that conductor. If we think about power cables, for example, that bring power to your home via substations, they have a low resistance to reduce the amount of energy or power that is lost due to the heating of the cables. Let's examine that in a bit more detail. So, if we think about a resistor and its purpose, so a resistor is a component that is designed to reduce the current. It's actually designed to reduce the amount of current flowing through a wire. A variable resistor has a resistance that can be changed, whilst a fixed resistor has a resistance that remains the same. And we know the symbols for that, for those two components. So many domestic appliances use resistance to transfer electrical energy to heat and light. So if we think about a kettle, at the bottom of the kettle it has a heating element, which is a coil of metal. And this coil of metal adds resistance. It resists electricity. So as we switch on our kettle and we pass current through the metal, resistance increases and causes the metal to get hot. And what that does is it heats up the water and causes it to boil. So we actually make use of this resistance. Okay. Now, why does that happen? So electricity in wires, as we know, is a flow of electrons along that wire. So as the electrons move along the wire, they start to collide with metal atoms. Okay, and those collisions make the atoms vibrate more, which then makes the metal hotter. So the more vibration there are, the hotter the metal gets. So here's a section of wire. We've got our copper atoms and we've got our little black electrons. Remember, they are delocalized because they are in a metal and they are free to move around. But because the atoms are starting to vibrate more, the electrons are struggling to move through them and they collide more. So resistance is a measure of how much a material tries to stop electricity passing through it. Just go back to that for a moment for you. So let's think about what effect increasing resistance has on the current in a bit more detail. So as I've just to kind of summarize what we've just been discussing. So as a metal wire is heated, the copper atoms vibrate faster. This means the electrons are unable to pass along the wire as easily. They collide more, okay? And these collisions will result in an increase in resistance. And when there is an increase in resistance, we get an increase in temperature as well. So our definition that we need to make sure we've written down, and I'd like you to kind of highlight this or put a box around this. So electrical resistance of an electrical conductor is a measure of the difficulty to pass an electric current through that conductor. I'm just going to pause for a minute to allow you to write that down. Okay, so we're going to look at Ohm's law. So Ohm's law looks at the relationship between voltage, current, and resistance. Now we know that voltage is also known as potential difference from our last lesson. So potential difference equals current times resistance. The amount of potential difference there is across a component is equal to the amount of current flowing through that component multiplied by the amount of resistance within that component. And we use a very straightforward equation known as V equals IR. Voltage equals current times resistance, or potential difference equals current times resistance. The units of measurement for that are as follows. So potential difference is measured in volts, as we know. Current is measured in amps, as we've already seen. Resistance is measured in something called ohms, hence Ohm's law. And this is the symbol for an ohm. So I'd like you to pause the video and write down the information on this slide into your book. Okay, let's have a look at an example question. A filament bulb has a current of 0.2 amps running through it with a potential difference of 5 volts across it. What is the resistance of the filament in the bulb? This filament here. So we write down in our equation. We're being asked, however, to find out resistance. So we are rearranging the equation to find R equals V divided by I. We're going to put into the equation our numbers. So R is going to equal 5 volts. Here's our 5 volts. And 0.2 amps of current, which gives us a reading of 25 ohms of resistance. 25 ohms of resistance. So that is the amount of resistance in the bulb, in the filament. Okay, let's try a worked example where I'd like you to write down as I go along these parts of the question. So my question says, calculate the resistance of a heater if a if a voltage of 230 volts causes a current of 200 milliamps to flow through the heater. Now, remember how we do our calculations. We should be identifying our readings first of all. So here is our resistance we want to know. Here is our V, and here is our I. Now remember, we want our current in amps rather than milliamps. So actually we're going to convert that by dividing 200 by 1000, which gives us 0.2 amps. Okay, so our equation is V equals IR. This time I'm going to substitute in the numbers first. So I'm going to put in a voltage of 230, a current of 0.2, and a resistance of R. R is therefore going to equal 230 divided by 0.2. that then gives me a result of resistance of 1150 ohms. So hopefully you had the same answer if you were ahead of me. So check your working, check that you understand that, because the next bit of work that I'm going to ask you to do is a lot of practice questions on a website called Isaac Physics. Now you may or may not be familiar with this already. There is a link to the Isaac Physics website to complete these questions on the Padlet and in your Go for Schools. So you will need to sign up to the Isaac Physics website in order to complete that. And I've put together a short video to help guide you through the sign up process, which is available again on the Padlet and on our YouTube channel. And you should be able to follow that through. It just needs your school email address for you to be able to sign up and complete that assignment in your own time. Good luck. Any questions, let me know.